Okay, so right now, and I am starting a couple of things I want to share first. Can I share both things at the same time? Yes, so. Okay, so thank you for joining the class today. It's very nice yesterday. I have not been speaking. I just spoke. I started speaking now. I have not started the class yet. Okay, so I'm sure you all can hear me. And as stated, every class, our class is being recorded. So if anybody has any issue with recording, please let me know. Otherwise, I assume that I have agreement from everybody. However, if somebody can't hear, just let me know on the message. Other than Srini, sorry, Srini can hear me as well. So if anybody cannot hear me, give me a message. Otherwise, I will assume that everybody is hearing me and everybody is seeing the presentation. If somebody doesn't is not able to see the presentation, please do let me know. Okay. So good morning. Uh, so basically, this is again an introductory class, right? So you can't see. Okay, Srini. Uh, okay. So anyway, so basically, what I'm trying to do is I'm trying to basically introduce you to the environment where we mostly will be working on Hadoop environment, right? So yes, data science can be done on many environments. We have Cloudera, we have Hortonworks, we have what do you call MongoDB, uh, Oracle, Teradata, a number of things. But that includes Excel, by the way. But predominantly, we will be using Hadoop. That doesn't mean that when you go to work in future on data science, you will be working on uh, only on Hadoop. However, again, having said that, you will not need to worry about it It is the responsibility of the infrastructure people who are what do you call tasked with basically uh, installing, configuring, and making it available to you. So the working and all these things would be almost similar. So all you need to know is Python and R and some statistical principles. If you know these things, you can work on any platform. However, let's go see how the Hadoop Hortonworks work, right? So let's take a look at the Hadoop architecture. So the Hadoop architecture, uh, not only Hadoop architecture, for that matter, any data system looks like this. The names of the things that you look at there might change. However, if you see the top layer level, the green, this one, they are divided as governance and integration, tools, security, operations, right? For example, governance and integration. There is something called Falcon. Falcon is used to take care of efficiently govern the files, data, and all these things. I will teach you. I will cover some of the things there today, which are necessary for you. Certain things which are not necessary for you, I will give a very high level overview. The rest of the things, whatever that is necessary for you to work on, I will give you along with the examples, and we will do some practicals as well. For example, I want to show you something, right? So this is Apache, and what we will be doing today is on Hive, and we also see how things work on. Sorry, one moment. I have not shared this particular thing as well. Okay, so you will all see start seeing Ambari pretty soon. I'm sure some of you might have seen this already, but everybody of you will see in few seconds time. I have already shared that. So we will work on some examples. We will create some databases and all these kind of things. Okay. However, we will go back to the presentation. So this is the Hadoop architecture. Now you will go back, switch in few seconds time. You folks will be switched on back to the PowerPoint presentation. Okay, so this is the Hadoop architecture. So it's not being shown. What I have done is, for those people who actually cannot see the presentation, what I'm done is I have uploaded this presentation onto the Skype itself. So I have uploaded. Please accept and open this on your personal laptops as well. Okay, so anyway, let me show you that. Why am I showing this? Where is my PowerPoint presentation? Okay. Yeah. Yeah. Okay. Sorry about that. So now, sorry about the small disturbance on the this one. So anyway, this is the presentation that I have sent you on the Skype. And also, please open that presentation, download that presentation, open that presentation locally. So the governance and integration bit of it, right? So that is actually to take the data from external sources, manage it properly, and load the data into the Hadoop platform. And the different kinds of tools. What are the different tools? We have seen Ambari yesterday. We have seen something called Zeppelin. These are the presentation layer. So basically, where somebody wants to do the data analysis and all these things, you would be using Zeppelin for presentation layer, Ambari for administration and all these things. And to do the data access, we have something called MapReduce, Pig, Hive, NoSQL, Stream, Search, in-memory database called Spark, and others like Hawk and Partners and all these things. And for security, we have something called Ranger, Knox, Atlas, HDFS encryption, and the other operations. So I'm not going to say a number of things right now, but I'm going to actually come one by one. Let me actually highlight something on the slide. Right now, we will be actually looking at this one. So we will be looking at Falcon in the governance and integration part of it. So what is Falcon? Falcon is a governance, and of course, you also speak about data lifecycle. So basically, what is data lifecycle? Data lifecycle is basically how there is data in some source system. So how do you take the data? How do you process the data? How do you manage the data and all these things? So the Falcon, the product Falcon, is a framework for managing data lifecycle in the Hadoop clusters. So if I show you Falcon here, okay, next slide. Oh, sorry. Uh, okay, I will show you Falcon. I have actually sorted this. Where is my Falcon? Yeah. Sorry about that. So I thought I would explain to Hive, and we will do some practicals on Hive right away. That's the reason I have actually, but I changed my mind and I wanted to explain to you about Falcon. Then we will go to Hive because we need to know how actually what does it Falcon do and how Falcon works. Okay, so then we will go to Hive and work on those things. See, basically, Falcon is a, as I said, is a framework for managing data lifecycle in the Hadoop clusters. So this Falcon basically addresses uh, it addresses the data replication, business continuity, like things, business continuity. What is business continuity? For example, data is coming from multiple sources. We don't know what the sources are. To do the data analysis, you need to collect the data. Now, all of a sudden, there's something happened, some breakdown happened, and all these things. So how do we continue the business without interfering this one, right? So and lineage tracing. What is lineage? There is a small term that we need to speak about lineage. For example, uh, the lineage is there is a data item. For example, what do you call uh, average temperature in winter in Britain since last 100 years is 20, let us say, is about minus 5 degrees Celsius, right? So now, where did you get this information? You have collected the temperatures since last 20 years in winter and you have averaged that. This is a data science process. Now, how did you get to that average number? So, in the data science, it is necessary for you to prove how did you come to that average number. So you have to go back to the transaction level data and show the lineage from top to bottom. How did you arrive, and what are the different evidences and all these things, especially in the financial industry. Okay, so if you have computed somebody's credit history, so how did you compute this credit history? So you have to go back to the data, transaction level data by drilling down and show the evidence. Okay, this person has so and so, so and so, so and so events in this person's life. So based on that, we have calculated. So that transaction level traveling back into the transactional level data and identifying the relationships between the data and all these things is the lineage. So the Falcon allows an enterprise to process single massive data set stored in something called HDFS. I have not discussed anything about HDFS till now, but I will in few minutes. Okay, something called HDFS. HDFS, for your information, is called the full form of it is called Hadoop File System. Okay, I will explain to you a little more about HDFS in a few minutes. Okay, so now the data set could be massive, but how the data set will be loaded into the Hadoop platform is the question. So it could be batch processing. Batch processing in the means, for example, you have data from multiple sources. You collect the data every night, once every night, or once every week, or once every 10 days, something like that, or at some frequency. Okay, on same day, at same time every week, at same time every day, at same time every 15 minutes or whatever it is, because you can't have real time data as per the you need data only as per the requirements. If you don't have real-time data requirement, you don't take real-time data. Okay, taking real-time data is tedious. So also interactive. So whenever I want data, I want to do something. Whenever I want to have some data, you can take the data then. And streaming applications. So for example, Facebook comments and YouTube videos and all these things can be taken from using Falcon. Okay. So basically, all this data, mind it, this is only an orchestration layer. It is only a data lifecycle management layer. It is not an ETL tool. There is another ETL tool. We will discuss about that again. Okay. So if we go back to the slide number 1. If we go back to slide number 1, yeah. So we have something called scoop here, right? This is something called scoop. So, so scoop is the tool which will allow us to take the data from source systems and load it into Hadoop system. So basically, under the watchful eyes of the Falcon. Falcon. What is the meaning of a falcon? Meaning of a falcon is eagle. So Scoop is a tool which will take the data and move in particularly, and but basically under the watchful eyes of this one. And I will actually show you the falcon thing. Sorry, I should have done this better, organized the slides better. I wanted to show you Hive first, but this is Falcon. Okay, so and what I wanted to show is, so Scoop, a tool called Scoop, based on the watchful eye of the Falcon, which is operated by an administrator, takes the data into some Hadoop using something called map, reduce, and all these kind of things into the enterprise data warehouse or document-based systems or relational databases, for whatever it is. Okay, and then the third one that we need to really discuss about is the Hive. Hive is again this one. Okay, so Hive is nothing but a database operations layer. So you can actually give your SQL queries and all these things here. So how does this Hive works and all these things we will see, and we will do some experiments. So meanwhile, what I want you folks to do is, I sent you a URL on the Skype. Can you please open that URL? I sent you the URL again. Can you please open that URL and do see whatever I am doing and try to follow on that URL. Okay. or what you can do is you can. Are you able to open the URL? If you are not able to open the URL, let me know, and we will go. Yeah. Don't worry. I'm going to give you those things. Okay. So, all right. So let's work on the Hive, and let's discuss a little bit about Hive first, and then we will go to Hive. Okay. So that's Hive, and so don't worry about the username and password yet. I will give you that while we are doing the exercise. Okay. So a metadata service that projects tabular schemas over folders. And see, basically, this particular Hive is a product. Again, Hadoop data platform is a suite of products. Hadoop is a framework, and there are n number of products, does n number of things. So you have governance products, you have tools, you have what do you call the data access layer, you have security layer, you have operations, and in each one you have different things, right? So enables the contents of folders to be queried as tables using SQL-like query semantics. Queries are translated into jobs. Execution engine can be Tej or MapReduce. It's not Tejar, it's Tej or MapReduce. Sorry about the typo there. So you can actually I will explain to you about MapReduce at a later point of time, today only. But this is how actually when you give a query, and don't worry about the query above, we will do that anyway. And this is how it actually works in the background. Okay, this background. Okay, so this is how it works. So basically, don't worry about this at this point of time, but the number of steps and all these things, right? So MR stands for MapReduce, Tej stands for the Tej. So we will discuss about MapReduce and Tej first before getting into practicals. So what is MapReduce? MapReduce is a framework for writing applications which process large amounts of structured and unstructured data stored in the Hadoop file system. Okay, so Hadoop file system, we just discussed about HD. We did not discuss. We heard about HDFS, Hadoop distributed file system. We will discuss about this in few minutes anyway. So once the data is already in the Hadoop file system, this MapReduce framework will actually process large amounts of structured and unstructured data. And the MapReduce actually can simplify the way developers write applications in their language of choice. Okay, such as, please remember, I am actually speaking about a dreaded thing here, and don't be afraid. So the developers can write applications in their language of choice. Please remember the word called choice, such as Java, C++, or Python. This table is there in the presentation. Please take a look at it at a later point of time, but don't worry about it this point of time. Okay, so I said Java. So immediately you will get a doubt saying that, do we need to know Java? No, you don't need to know Java. You can use Java as well in addition to C++ or C Sharp or Python or MapReduce or R, whatever. Okay. So one of these things will be sufficient for you. So our favorite tool for our class is Python and R. So don't worry about the rest of the languages if you don't know. If you know, that's great. That is okay. That's not great. Okay. Scalability. MapReduce can process petabytes of data stored in HDFS on one cluster or multiple clusters. Also, it can parallel processing. What is parallel processing? Parallel processing means that MapReduce can take problems that used to take days to solve and solve them in a few hours or minutes. Okay, once upon a time, some petabytes of data, it used to take days, a number of days to solve. For example, there used to be called some programs called or softwares called MATLAB and all these things. And if you run a program on some huge data set and genomics data or meteorological data, that particular program used to run for almost 7 to 10 days and finally give the result. And that result could have been erroneous result. Then people used to set right their program and run it again 7 to 10 days again and all these kind of things. Now, such kind of things are now made possible with MapReduce to speed up the operations, and the speed will be in hours or minutes sometimes. Recovery. MapReduce takes care of failures. If a machine with one copy of the data is unavailable, another machine has a copy of the same key value pair. I'll tell you what is key value pair later, which can be used to solve the same subtask. The job tracker keeps track of all. And minimal data motion. If you go to minimal data motion is like the data movement from one place to the other is minimized with the MapReduce because when the data moves from one place to the other, it costs money on the cloud environment first of all. So basically, MapReduce will reduce the data movements. Okay, so that is about MapReduce, and we will now discuss about how the MapReduce works. MapReduce, you can note it down at this point of time, a little bit of notes, right? So the MapReduce splits large data, for example, some petabyte data is there, into independent small pieces called chunks and organizes them into key value pairs for parallel processing. The parallel processing improves the speed and reliability of the cluster, returning solutions more quickly with greater reliability. Okay, so there are two functions in the MapReduce. That is the name. That's the reason the map and reduce came into picture. The functions are, the first function is called map and the second function is called reduce. The map function divides the input into ranges. I will give you example when we are doing this practicals. Okay, by the ranges could be by input format or something else. Creates a map task for each range in that input. Okay, and the data will be processed. The reduce function then collects the various results that are created by the map function and combines them to answer the larger problem that the master node needs to solve. Okay, that is what you need to know till now. So this explanation will you will be able to understand a little bit more when you are doing the practicals actually. Likewise, we will also learn a little bit about page. These are all overviews, right? And you need to, after learning about Tej, we need to learn about two things, overviews about two things. The other things are, one is called Yarn, the other one is called HDFS. So we will discuss about these two things. So we will discuss about Yarn, but Tej is an extensible framework for building high performance batch and interactive data processing applications, coordinated by something called Yarn. So now, before actually going deeper into Tej, what I would like to introduce you to something called Yarn. What is Yarn? Yarn is in our basically English language or any other language, Yarn is a piece of thread, something like that, or making a piece of thread. So Yarn is a part of core Hadoop project. Okay, is an so basically it is a architectural center of Hadoop that allows multiple data processing engines, as such as the rest of the things, Hive, Tej, and all these things. The number of things, whatever you have seen here, right? So all those things will be what you have seen. You have seen these things. So, for example, this is Yarn. This is the operating system of the Hadoop data platform. Okay, and the HDFS is the storage system. Is basically see data management. So Yarn is the operating system. Like for example, if you take Oracle, you have some file system. I don't know what that file system is called. Likewise, DB2, you have some file system. If you take Windows NT or Windows 2000 or Windows whatever operating system version right now, the disk, if you look at the disk things, right? So if you look at the properties of the disk, it is called, the file system is called NT file system or Windows file system. Likewise, we have for Hadoop, we have Hadoop distributed file system. What is the difference between normal file system and distributed file system is, normal file system, for example, if your Oracle file system or any database file system is limited to that computer unless it is a grid database. Okay, Oracle 11G onwards, the data can be stored in multiple computers. But at this point of time, like Windows NT, Windows file systems and all these things, you can store data only in that particular computer, connected in many disks that are connected to that particular computer. Okay, but in Hadoop distributed file system, the name distributed came because the Hadoop framework can be installed in something called clusters. So on many clusters, the Hadoop can be installed. It can be installed in multiple clusters. The same framework can be installed. So data will be distributed across computers, across grids, not only on the disk drives on this computer on which it is stored, also in multiple computers it can be stored. And the HDFS is a very efficient thing that it can orchestrate the data very efficiently, can access the data very fast. And how does it happen and all these things, we don't need to worry about it at this point of time. All right. Then we have something called Tej. Now we will go back to Tej. Tej is again is a orchestration, the part of the Yarn. So Tej is Yarn based what do you call framework. It is high perform. It helps in doing the high performance batch and interactive data processing applications. Okay. So Tej provides a developer API and a framework to write native Yarn applications that bridge a spectrum of interactive and batch workloads. So So basically, we will see about Tej in much more detail at a later point of time when we are doing some practical safe time problems. Okay, so then we have something called slider. So what is a slider? Slider again is a similar thing like Tej. So basically, it is a again. One moment, please. I'm looking into the. Slider is a this one. I'm talking about the slider here. This is the slider, right? So if I highlight, slider is a framework for deployment and management is of this long-running data access applications. What are the data access applications? We have MapReduce, we have Pig, we have Hive, HBase, some Storm, Solar, Spark, Hawk, etc., etc. So, uh, so right now we heard about Falcon, we heard about Scoop, which is a, and also we will learn a little bit about Flume, Kafka, NFS, WebHDFS, and all these things. WebHDFS is not there anymore in the later because it's all HDFS now. So we don't need to worry about WebHDFS right now, but we will be worried about we will hear a little bit about Flume, Kafka, and NFS in a minute, and after that we can jump into actually Hive, how Hive works. We will see how Hive works and all these things. So let us discuss about Flume. This is Flume. Okay, this is Flume. So what is Flume? For example, you have server, a web server somewhere, okay, or a database server somewhere, or a network some server somewhere on the cloud or in your data center or whatever it is. So, and a lot of people will be accessing these servers from their computers using their client softwares. Okay, like for example, if it is a web server, what is the client software? The client software could be either Internet Explorer or Chrome or whatever, right? Likewise, if there is Oracle server, then you have something like SQL Plus, Designer 2000, Discoverer 2000, and all these kind of tools, right? And then business objects, etc., etc. And a number of servers, network servers, you will be logging in using your Windows machine and all these things, using your clients. So, however, these servers, whatever they are working, they will be creating huge number of logs, and these logs are created on the real time. So Apache Flume is something which will actually will be able to capture all these logs in while they are being streamed into the HDFS. I told you what is HDFS, Hadoop Distributed File System. So where the data will be stored. Okay, that is Flume. And we will see all these things in 1 or 2 days. Starting today. Then we have something called Kafka. How many of you people have heard about ESB, or service-oriented architecture? So basically, Kafka is a, I don't know what is the meaning in what language it belongs to, but it is a fast, scalable, durable, and fault-tolerant publish and subscribe messaging system, just like our enterprise service bus and service in the service-oriented architecture. So Kafka is Hadoop specific, Apache specific. and it is used in place of traditional message brokers like I'm sure some of you might have heard about these things and some of you might have not heard about these things. So don't worry if you don't hear about these things. We will not be working on this because we don't need to worry about this in our entire career. And I don't work on these things at all. As a data architect, I know what are these things. I need to be aware of these things, but I don't need to I don't need to have any knowledge on these things. Okay. Kafka works in combination with Apache Storm. We will discuss what is Storm in later date. Apache HBase. We will see what is HBase. We will do some practicals using Storm and HBase, and also Spark for real-time analysis and rendering of streaming data. Kafka can message geospatial data from a fleet of long-haul trucks or sensor data from heating and cooling equipment in office buildings. Or I told you yesterday that I have done a project where there are certain things called pigs, which are sensors running in the crude oil pipelines or gas pipelines, huge 6-footer pipelines. I'm not sure some of you might have seen James Bond movie. In one of the James Bond movie, Pierce Brosnan will be in the some capsule and in oil pipeline, and they go, right? Such kind of, these are called pigs. These pigs will actually collect data and stream the data back. So there you can actually use the Kafka. And previously we have also seen Flume. So Kafka and Flume together can actually push the data into HDFS file system, and then you can use using either HBase or Storm or Solar or Spark and all these things, which we will see in coming few days. Okay, so the next one is NFS. You don't need to really know about this, but anyway, it's nothing. It's basically NFS and Web HDFS. NFS used to stand for Network File System, but Network File System as well as Web HDFS, both of them now merged together. It is just HDFS. So as I said, HDFS is a distributed file system on the top of the data operating system called Yarn, and it is a data management layer for Apache Hadoop where data will be stored. Now HDFS is HDFS is a Java-based file system that provides scalable and reliable data storage, and it was designed to span large clusters of commodity servers. HDFS has demonstrated production capability of 200 petabytes of storage and a single cluster of 4,500 servers. So HDFS can spread across up to 4,500 servers, and a single computer can store data up to 200 petabytes of storage. So this is more about storage, nothing about anything else. So again, the features of it needs to know where that specific data set is stored, in which out of this 4,500, up to 4,500, doesn't mean that it will be stored in all 4,500. So it could be one computer, or it could be up to 4,500 computers. So when the data is stored in like multiple computers like this, you need to know where each data set is stored, which computer that particular data set is stored. So basically it knows where it is stored. And minimal data motion, again, the data motion, movement of data from one computer to the other computer costs money. So basically HDFS will take care of minimal data motion. It will not move the data unless it is absolutely necessary, irrespective of the operations you do it. And uh, all kinds of data capabilities that your hard disk drive or your database softwares will be having, all these kind of things. And of course, we will HDFS cluster is comprised of something called name node, which I will discuss this in detail, because you need to know this in detail when you are working on the data science. So for this particular HDFS architecture itself, I would like to take at least half an hour. But before that, I would like to do some experimentation. So let's go to that experimentation. You know the fundamentals of HDFS, and you know the fundamentals of some other things. But before doing anything, what I would like to do is I would like to explain to you some of these things. So another 10 minutes, bear with me with this theory, and then we will go into these things. Everything we will see in our Hadoop framework. So one by one, we will see everything on Hadoop framework. Uh, so first of all, we have discussed about MapReduce. MapReduce, there are two functions. One is map function, the other one is reduce function. And we will discuss a little bit on the pig. What is pig? Pig is a scripting engine. It is basically, you know what is Yarn now. Yarn is a data operating system. So basically, Pig is a scripting engine. It manages the scripts that you write, and using these scripts, you can either write ETL programs or you can write data analysis queries. So it is basically the features of Pig is it is self-optimizing. So the performance can be, you don't need to worry about the performance of the query that you give. That Pig itself will take care of the what do you call performance. And easy programming. Complex tasks involving interrelated data transformations can be simplified and encoded as data flow sequences. So let us see all these things at a later point of time. Now we will see another thing. What is it? The next one is Hive. Okay, so we will see the some of the tutorials on the Hive. If I can actually share the lab itself, give me a second. I am sharing the lab now. So let's go from the Ambari. Okay. So whatever we have discussed till now, we have discussed about certain things, like we have discussed about MapReduce. Right now, the MapReduce is version 2. We have discussed about Yarn. Yarn is the operating system of the database. We have discussed about Tej. We have discussed about Hive. We didn't discuss about HBase. We will discuss about HBase at a later point of time. Pig is a scripting engine. We have Scoop is a what do you call is a data movement. This one we didn't discuss about Woozy, Zookeeper, etc. We discussed about Falcon is a data lifecycle management engine. We will see how it works. Storm we will see. Flume we will not see. And we will not also look at Kafka, Atlas, Knox, etc. because we don't need to worry about those things. Ranger, Slider, Spark, and Zeppelin. We will be using Zeppelin extensively in our data science course. Okay, so first of all, the basic fundamentals of this one you do here is the Hive. So what is a Hive? I told you what is a Hive, right? So what is a Hive? Hive is a SQL query engine, basically, which works on the what do you call on the Yarn framework, which is the database operating system, and the data stored in the HDFS will be queried by Hive. It can explore the data, and you can also give ad hoc queries on the data. So you can create ad hoc reports and all these things, right? So let us do some practicals. So I will start with something called what do you call, one moment. I will start with a little bit of so Hive. There are, if you look at this, there are two databases. You can see the default and Exademo here, right? So these are two different databases. So for example, I want to create a database called Xbean. See? So basically, what is the difference between a database and a data table? Data tables are stored in the database. So basically, you can create data basis based on the what do you call requirements. So when you create try to store data, you need to know what kind of okay, I will take care of this later. Okay, so basically, you need to know what kind of requirements are there. Do you need data to be stored in multiple databases, and where these databases have to be stored, and all these things. So we will see how to do that. But how many of you have heard about IoT, something called Internet of Things, right? So I will just give you a small example. So, because basically I want to actually do some practicals on this. So let us say I'm actually preparing data at this point of time in another screen, and actually looking at it, and I will show you. We have something sample data. This sample data is there on my laptop, and I would like to show you that sample data, how we can actually load this sample data. Okay, I just want to see where the sample data, I'm actually exploring where this sample data is. And then, yeah, in the data science, in samples folder, you can't see, but I'm just looking at my this one. Okay, now I got the files. Okay, we have some sample data. So what does it do? What is this example about? So what are the different things? How do we these things, right? So we have something called like for example, we have your parcel offices, right? So you go give a parcel to send to some of your friends. So those parcels will be traveling on some trucks, right? So now what I want to do is I want to see how these trucks are traveling, and what are the drivers doing, and all these kind of things. At what time the truck started, at what speed, and the number of things, and what locations the trucks are there, and all these things. So for that, I have some sample data, and I would like to show you. So basically, what we need to do, we need to we need to upload the data into Hadoop. Right now, the data is there on my laptop. So how do I upload the data? Okay. So the data is already there. So in this tutorial, what we will see is so basically it will make you aware of the HDFS. You will be aware of, you will be able to use HDFS. You will be able to use Hive. You will be able to use something called Pig Views, and also you will be able to use Apache Pig and Apache Spark, and data visualization using Apache Zeppelin. Okay. So now we have to load the data, sensor data, into HDFS. So in HDFS, we have 3 different databases at this point of time. These are already stored in the HDFS. So out of these 3 databases, we will see, we will take XBean as the database. Or shall we, because because we have created a database called XBean, we will see how we can. Meanwhile, I would like to show you, I would like to go back to Ambari. I am leaving Hive. I would like to go to Ambari. The reason is I want to see the HDFS files. Okay, can you all see this? So how did I go to HDFS? So this is nothing like your, nothing more than your Unix file system, or or your Windows file system. The only difference that you won't see on Windows is this area. Okay, so anyway, we have this is HDFS file system. So within this, so now we have to load the data into HDFS file system. So I have data, I want to load the data into HDFS file system. How do I load the data into HDFS file system? First of all, let us see what happens here. Okay. Yeah. Let me go back to root. So let me go back to Hive. I want to show you something. So this is the database with what we have created. Let's say I can also create database test. Very simple. Huh? You don't need to worry about anything. So that is how I created the database. So I have now, right now, what I have done is I have created another database called test. So likewise, you can create any number of databases. Simple statement, create database with a name. Okay. So now, if you look at the Hive HDFS again, I just wanted to show you this one, right? That's the reason I have actually went back to Hive and created the database. So if you go to Hive folder here and something called warehouse, did you see we have sample underscore 07, sample underscore 08. These are the 2 folders already. There is a testdb, xademo.db, and xbean.db. So there are number of. So previously, when we have tried to see, this testdb is not there. Test.db is not there. Okay. So that means when we have created the test database, this test.db has been created. So what I wanted to show you here is, see these databases. For example, I can create one more database. Create test2. Create database. Okay, it is now succeeded. In apps, in Hive, in warehouse, you see test2 now, right? So that means basically the databases are created as folders themselves. So in Hadoop and environment, all the databases are stored as folders in file system. You don't have to worry about. Now the beauty of it is, I will go back to my root folder, okay, and I will say there is a user folder here, right? And there are multiple users, and there is a user called Maria_dev. By the way, if you want to take a look at it, and if you want to do some experimentation along with me, it is okay. So the username is Maria_dev, and the password is the same. Okay, so but I recommend you to see me first. Okay, so in Maria_dev you have different, and you can also create what do you call, new directory. So let us say I want to basically in this user I want to create a project. This project, let us say I want to create a name of a project called geolocation. So I'm not creating a database here, mind it. I will be creating database only using Hive. So at this point of time, I have created a project called geolocations, and I have created a folder for that. Now I want to load the data. So I will upload the data. So the data is in the form of so my data is there here in this folder. So these are the two files. I will copy and take both one by one, because we can't do multiple files. And I'll say upload here. I have taken two files because of certain reason. I will tell you what is the reason. I can do it using one file itself, but I have done it using two files because a specific reason. I wanted to show you that. Okay, so now the data is there in the Hadoop file system. Okay, so we have not done any ETL and all these things. We have just uploaded the files using file browser. Okay, so very simple way of loading the data. So now the data is not there in the Hive yet. If you look at Xbean, I want to create the data in the Xbean folder. There are no tables in the Xbean folder. There are some tables in the default folder. There are some tables in the Xademo folder, but I don't have any tables in the Xbean folder, Xbean database. Right? It's empty. So let us create this project in the Xbean data, database. Okay, how do I do it? So now I have this data already, and I have uploaded this data. So once I have uploaded this data, there are two ways of loading the data. One way is very simple. I go back to very simple. You will be really surprised the way the data will be loaded. So where is the data? Is in user, and we have user, we have Maria_dev, and we have geolocations, and let us say what am I doing is I am clicking the arrow button here, that is move, and going back to the root folder, and I go back to apps, I go back to Hive, I go back to warehouse. This geolocation.csv is coming with me, and I go back to HB and I say paste. So basically, I copied and pasted the file called geolocation.csv into this xbean.db folder. Simple, nothing. I have not done anything. So let us go back to Hive. Select star from xbean.geo. What is the reason? Let's go back to oh, see, spell mistake. We can actually look at the history. All the successful are failed. Select star from xbean dot geolocation. Ah, is the most simple example. Somehow the data is not coming. So why this data is not coming into this? You can actually see the data as well here. Give me a second, please. There is some problem. Let me sort that problem. I didn't think the problem will arise here. Uh, no need. We don't need to create the table and upload. So no, we don't need to create the table and upload. No. No, that's not it. That's not the reason why it is not working. Uh, Probably it is taking some time to. One moment, please. I'm just checking the background. Okay. Hmm. So I have actually could upload the table. I had to basically do something in the background, but I will tell you what I have done at a later point of time. Okay, right now the HDFS thing didn't work, but of course, let me. Don't tell me I've uploaded this thing. Yeah. Okay. So for some reason, the HDFS thing is not working. So what I have done is we will see this query later. What I have done is I have actually taken the data from my personal laptop, for example, geolocations, and also I have selected what database I need to, and what is the table name, and what are the columns. For example, if I select this, what happens? The whole CSV will become the data itself. If I select this, the first thing will be the column names. Okay, sorry about that. This HDFS thing did not work properly. I don't know what is the reason. I will check that. I don't know why it is not able to. So if you look at, you refresh this. If you look at the XBean, we have both tables. If you want to see the data, so from geolocations, it is happening, and you can see the data here. Okay, likewise, you want to see the data, you want to see the metadata, you know the metadata, right? So the metadata is like this. Okay, so I've just limited the, we can do whatever you want to do. Okay, so you can query the data as you want. So the query is running, the query is this one, right? So basically, let us take a look at the what do you call data table attributes: truck ID, driver ID, who is the driver, event, what kind of event, latitude, longitude, the place where geolocation, city, state, velocity, event indicator, idling indicator, and all these things. And driver ID, truck ID, model, June 2013, how many miles this driver ID for the truck he has done, and all these kind of things. So there are number of columns that are there, and the data is there. Okay, so how do we actually analyze this data using different things? Okay, and how we can actually so there are too many columns here in this, and there is huge amount of data also. So for example, if you want to see the data, you can either click here. That will actually create a query for you, and the default query will be limited to show only 100 items in the data. The rest of these things you can see. Okay, so we have created two tables. I am sorry, this HDFS thing did not work properly, but I will show you in HDFS what happens here. Okay, okay, I have done this so many times and I made a mistake. That is the reason you are unable to see the data and the table. I am sorry, it is my mistake. So what is the mistake that I have done? I have not created the tables in the format. For example, I can create a new folder. I need to create a new folder, sample table. I am sorry, this is my mistake. Sorry about that. And then on the sample table, I have to basically upload a file. Okay, I'm just showing you to show this. Sorry about that. I have done this exercise so many times, and I just missed it and wasted some time. Sorry about that. So in XBean, we have to refresh this. In XBean, no, sorry, it's not my problem. There is really some problem in HDFS. I will sort that out. So anyway, so you have seen how to load the data. There are, and of course, you can also move data from, for example, you can create table like trucks real. As select star from trucks. So from one data to a table XBean dot. Why am I doing that? I'm doing that because there are multiple databases here, and it doesn't know from where it has to take and where it has to load the data. So it will load the data from this table, and it will create a table called trucks underscore real, and it will, the query has been submitted. And data is being read at this point of time. The query is being recorded, and the page session is being created. And the map reduce is working. Remember, map reduce, I said it will let you load the data very, very fast. Yes, but it took some time, even though data is at a lower volume, because of the lower volume. It is higher volume, it would have taken much faster. See, the data trucks real has been created. So the data has been copied from a trucks table into this one. So for example, if you look at it, it is the same thing. So you can compare the tables and all these things. So what we have done, we have done we have created a database, we have created tables, and we have loaded data into tables, and we have transferred the data between two tables. And I'm sorry, the previous thing did not work. So anyway, we will see how it goes. Okay, but prior to that, we will also do some analysis work. Okay, so for example, I have this query stored in my laptop. So I would like to, instead of writing queries, typing queries here, what I have done is I have stored some queries. So this query, what does it do is, it will, what I would like to show is, So basically, it is creating a table called truck mileage. Uh, uh, you can see stored as ORC. I will teach you what is meant by ORC at a later point of time. We don't need to learn about this now. I just want trying to sorry break this. Uh, okay, the just let us. I will send you the query on the Skype as well, so you can actually take the query on its face value, read the query at a later point of time. Okay, so basically it is creating a table called trucks mileage using number of what do you call a bit of this one, right? So what is happening, right? The query is succeeded. There is a new table called uh, trucks mileage has been created. Truck ID, driver ID, date. So, for example, truck ID is this much, truck mileage dot driver ID is this much, June 13, 9,217 miles that mileage has been run. The gas, in the sense, in US, these are all United States, what do you call, the units. So gas is petrol. So how many liters of gas, how many gallons of gas has been used, right? And all these things. So, and of course, MPG. You can actually now select, let's say, truck, sorry, truck ID, comma, gas, MPG. Okay, so you can select only the things which you need, or you can also add driver ID. Okay, so basically this is a little bit of analysis we have done here, right? So what we can do later, what can also do is, um, okay, explore sampling of data and truck mileage. Now I'll see if we can actually do this here. So I am actually trying to calculate average mileage. The query is, so basically there is a function called average in the, so for each truck, how much average mileage has been listen. So truck A1 has been, and you can actually group by, so directly. So what we can do is we can also create another table for this. Create AVG MPG as, sorry, okay, Sorry about that. My space bar has not been pressed properly. See, this is the table that we have just created. Okay, so basically, this is how you actually, what do you call, run the queries on the data. Okay, so excuse me, sorry. The next one is no, you have now what we also can do is some same DSC. We can actually do the analysis on the Zeppelin. So Zeppelin is a presentation layer, right? So using the presentation layer, how do we actually analyze truck? Okay, so I have created a notebook, and see Zeppelin. If you look at the interpreters that are available, there are so many interpreters that are available. Okay, Hive. So if we have to actually create queries for Hive, you have to. So what we have to do is we open this percent Hive, select star from what is it? This could be right or wrong or whatever. Is it trucks or truck? A moment, please. Or we can also why interpreters. Okay, they change the name of the interpreter. Okay. Looks like there is a problem on the configuration of the interpreters. I will get to the bottom of it. But anyway, so let's go back to our Hive thing. Okay, let me set right the interpreters. So the username and password is, I will keep this lab open till the end of the day today. I want you folks to create. Now I will show you, I will send you some URL where there are good number of tutorials, and including this tutorial is also there. So you can actually work on these tutorials, each one of you, and you can actually send me a WhatsApp message or whatever it is if you can't do certain things. Anyway, okay, this is census data tutorial. Okay, so there are some lab tutorials that are there. You can do these tutorials on your own. Very simple, but in case if you are facing some problem, let me know. And remember, whatever you are doing here is a very, very basic data analysis. Okay, so we are not doing anything using Python and all these things right now, but we will look into those things. We will look into some ETL things at this point of time. And don't So we heard about pig, right? So we have seen pig. What is pig? Pig is a scripting language. So we will do a little bit of sample using pig. Okay. Let me first of all create a table using my XBean database. I will actually say specify XBean risk factor, and I am creating a table called risk factor in the XBean database. Okay, so once I create this one, whether this table is existing in the database or not, see, risk factor, driver ID, events, total miles, risk factor. Okay, this is the data. So I want to create a pig script. So what you have to do, if you have to create a pig script, go to pig in this, and it will actually send you to pig view, and this pig view actually will you will be writing some SQL on this. Okay, so to write some SQL, what you need to do is you need to press on script. There are no pig scripts available. There are no pig scripts available here. So what you do is you click on the script and say you have new script, and give a name to the script. What will you name the script as? Let us say give the risk factor dot, and all the pig scripts are oh, okay, there is a extra T here. So all the pig scripts are stored with the .pig extension on the file. Okay. So even when you do this, when you say create, a pig script is created, and when you and now what you have to do is we have to use a function here called catalog loader function. So, and see, basically, this particular catalog loader function is used to load data into pig. And this allows the schema to be shared across different tools. So how do we write this catalog? This one. So we write the catalog. So A equal to, and between while you are writing this particular thing, right? Between this whatever A or whatever, between A and load, there should be an equal to, and we will discuss all these things when we are actually learning the pig scripts later, right? So, and between A and load, there should be spaces, and also there should be is equal to. So geolocation is the name of the table using hive catalog pig hcat loader. The script above loads data, in our case, from file name geolocation using hcatalog. Copy and paste the above pig code into this packet. Okay. Before that, we also have to okay. So now so this is of course pig scripts can be much more it is running at this point of time. It is actually doing the script. Okay. I should have actually added all these three different these things in this one, but at the same time I wanted to show what is happening. Okay. So this script is completed. It actually stored the local data into something called pig. So now anyway, but this is a script. So a script will have multiple commands. So basically, what is a script? You have select star from so and so and so and all these things, right? But we can have a number of what do you call commands in a script. So once we finish this, I will. I have the scripts commands written in my this one. So now what you have to do is you have to uh, so basically we have used something called a library, right? H. I will tell you why we are doing all these things at when we are actually learning about pig much more extensively. Okay, so now we can actually execute this one. Now the job started. We have used the H catalog argument. Uh, uh, okay. I have not selected it. I thought it is selected. So whatever we have done till now, we will basically what do you call the how do we actually work on pig and all these things. We will learn extensively how we work on these things. Okay. I guess there is some configuration problem on the environment. I will tackle that. But this is how. But anyway, this is just a sample of how we actually work on the pig, right? So it's not the what do you call. And also again, remember we will be doing many things in the uh, so many things in Python actually. Somehow, one moment. Let me see if I can actually work on reporting. So there looks like there is a configuration problem on the server. That's the reason this thing is not actually, it is being successful, but it is not actually showing the data, if I want to actually show you what has been generated, I can, it is generating a empty file. It's actually generating an empty file. So I will take a look into it, but we will be learning about Hive scripts and Pig scripts in next class very extensively. So we will go from there. Okay. Looks like there is a. Okay. Dinya, this is Ram. Are you listening? Are you able to see the whole thing?
Yes.
Okay. So, any questions from you today?
Initially, you were telling that there's a life cycle, data life cycle, which
Right,
is.
right.
I don't know what is the life cycle of the data.
So basically, life cycle of data is once you have some data at the source. For example, you have some data in a Twitter.
Okay.
Okay, you have to download the data from Twitter, and then you have to load the data into the Hadoop framework, or you download the data from Facebook and load it into Hadoop framework,
Okay.
or data from any other source system. It could be Oracle or whatever it is. So you won't be just taking the data and loading the data into the database wherever. So you would be actually running this data through n number of steps.
Okay.
Okay, so basically, what will you do is you will actually profile the data. You need to understand the data first of all. What kind of data you are loading? For example, if you take a look at this data, right? One moment, I will show you something. Uh, for example, you are actually one moment. Let me. Okay, you can see the SQL, sorry, Excel. Right, you can see the Excel here, right?
Yes.
So, yeah, this Excel, when you are looking at this Excel data, okay, see, the data will be coming to you, for example, like this.
Okay.
Okay, so if you load the data directly like this, okay, you don't know what is what. What are these numbers? What is this model? What are these things? So you need to identify what columns, for example, row number one. This is something which actually defines the data, right? So we need to take a look at the data first. We need to identify what the first row is doing, what kind of data is there, is the what is the data type of the data, and all these things.
Okay.
Okay, and you need to plan that for the data to be stored in the HBase. Of course, in this example, whatever we have done in the lab example, whatever we have done, we just copied and pasted everything, right? So
Right.
that is not how we do it. What we do it is we actually create what do you call uh, uh, we actually create uh, we actually take this data through a process. So first of all, we have to profile the data. We need to understand about the data. What is the first column? What is the second column? What is the first column data type? What is the second column of the data type? And what will be the identification? what is the primary key, foreign key, and all these kind of things, right? So, so identification, preparing the data to be loaded, and finally loading the data, starting to end is the cycle. So this is called data life cycle. Just like software life cycle, software design life cycle, you have data life cycle. So basically, in today's class, what happened is we have seen a flavor of the things. Yes, some of the things didn't work. I didn't worry about configuration yesterday because I thought the Azure Azure environment will configure everything automatically. Sorry about that. This Coming to sandbox. Sandbox is a play area. So sometimes the sandbox may not 100% mature. So what I will do is I will also install HD Insight before the class next class. So and these kind of problems will not come. So what happens in this case is what happened today is we have just seen how the Hadoop framework is there. What are the different kinds of components are there? Like what we have seen. We have seen Falcon is in a watchful eye. It will take care of data, looks at the data, identify the data, what is meant by each column, what is meant by each row, what needs to be done, what are the data types and all these things, and then store in the database. Okay, and then Hive is to look at the data, query the data, and do the little bit of analysis. And remember one thing, using Hive, you won't be able to do extreme analysis. So for that you need Python. So we will learn Python anyway. And then we have also looked something called Pig. Again, very starting fundamentals about it. Remember, this is week 0. Okay. So, and then we have also seen a Zeppelin tool. And of course, that Zeppelin tool has some configuration problems. Some of the interpreters, they did not work properly. So I will take a look at those things. So for example, if I look at Hello World tutorial, let me see if this thing works. Okay, everything changed. Okay, PySpark. All right. Okay. So anyway, this is only for fundamentals. You won't be working on this Zeppelin in your life as a data scientist. Okay. So anyway, that's a different thing. But I will worry about the configurations and all these things. Mostly, we will be working from next class onwards something called HD Insight, which is more robust Hadoop installation than this one. Okay. So, and also what we have seen is I have sent you the presentation. Did everybody download the presentation?
No, Ram, we haven't got the presentation. I mean,
Oh,
send it to.
it didn't come in the Skype?
Oh, Skype.
I think it is requesting the permissions.
Yeah, you permitted.
No, it didn't come.
So it's basically asking you to asking me to rejoin again to get the presentation because there is a, authorization is required, something it is asking. So I stopped it.
Okay.
It gave an option as soon as you shared the presentation and it disappeared.
Okay. All right. So what I will do is I will, if I send it by WhatsApp, will you be able to this one?
Email Is it possible to
Google
be?
Drive will be ideal because
Yeah, yeah.
WhatsApp.
Sorry. Okay, I will share the Google Drive. This one, I will put it in the
Getting
Google
back
Drive.
from the WhatsApp to the
Yeah, I
laptop
will
will
put
be
it today
difficult.
itself. Okay.
And
Yeah.
one more suggestion, if this tutorial link is sent to the email, or that should be easier, because Skype I've saved it, but if I send these links through email, or it'll
I will put
be,
it in the Google Drive itself.
yeah, that will be useful, because Skype, it gets lost after the call.
Yeah. Praveen, how are you?
Hello, good morning. So, first of all, there are so many words, there's so many the terminology,
Mm-hmm.
so that we discussed a lot of our points in a
Short time.
little span of time.
Mm.
So that's why there is a confusion in the terminology you mentioned in a class. So all those Flume, Apache, Ambari, then Hive, Pig, Scoop, Ooze, Zip. So these days, these all words really a little bit confusion for me.
Yeah.
Solar, Storm. So that I want to be go through one by one in a clear. So that then I can, if I understand myself
Yeah.
through net or in a Google, so
No,
that I can
you don't need to. You will get a presentation from me by email. Sorry, and the what do you call on WhatsApp? I will send you the link to the presentation. You can download that presentation. Okay, you will see. Basically, there are number of things in the Hadoop framework. You need to know some of them, not everything.
Yeah.
Okay, so like for example, you need to know Hive, you need to know Pig, you need to know Spark. Okay, but rest of the things like Kafka and all these things, Flume and all these things, you don't need to worry about it. Okay.
Yeah, but you not to worry, but it is coming into our so in a day-to-day life. So that's what.
No, you will not see. I am introducing you these terms. If you hear these things, you will not be surprised. However, as a data scientist, you will not be working on these things at all. Promise.
Okay.
Okay.
But we should know about it.
You should know about it. Okay. See, basically, if somebody says something, you don't have to really say, "Oh, I don't know about it." So, right. So, you need to know about this. You need to hear about this. You need to really basically see what is what and all these things. But at the same time, you don't need to be an expert on these things, because you are not being trained to become a Hadoop administrator, Hadoop installer, or a Hadoop programmer.
Yeah.
Okay. If you are becoming a Hadoop programmer, you will not be doing many things.
Okay.
Okay. So what you are doing is you are actually learning how to become a data scientist, how to look at the data, what are the different things that are there in the data. However, what I will tell you is, okay, in the Hive environment, I stored some data. Can you analyze this data and give me the projections for next 10 years about the weather patterns? Okay, you need to know what is meant by Hive. Oh, Hive is a database. Okay, you don't need to know how to work on Hive, because you will be working on Python on your computer. You will be getting connected to this big data environment, but you will be working on Python.
Yeah, first of all, we have to expose to this environment. I think it is not possible in a 1 hour, 1 day. So I think slowly that we have to be inculcate these all terms into our minds. Then we have to work. Then there's a little bit confusion will be there at the starting point. So definitely that is going to be clear. If we go on further, move little bit further. So I think as per my expectations. So for overall scenario, according to me, that is not reached fastly into my expectations. But anyhow, I'll put a step one by one.
Okay. Okay, very good. So, all right. So, Srinivas,
Yes, can you hear me?
yeah, I can hear you.
Yeah, I think it was good. We couldn't capture a lot of things today due to environmental problems, but hopefully we got introduced to the framework. We got introduced. The other big thing was a lot of new terms have, and we are trying to digest all these new terms
Yeah,
because we are hearing it for the first time.
yeah,
Uh, One suggestion from my end is every time we talked about this new topic, where you got this presentation of talking about the Hadoop architecture and framework,
mm,
where you talk about your integration, governance, tools, security and all this stuff. If we can pause for a moment after every topic, probably maybe we talked about Hive and we talked about Pig and we jumped very quickly there.
yeah,
um, I had to I had to scribble down a lot of notes, and then I had so many questions about each of those topics. But yes, we will explore each topic, in the coming weeks.
mm,
But at that point of time, there was so much of curiosity as to how it would work in Hadoop
right,
compared to your conventional databases, please.
right, right. Yeah. See, basically, as I said, this is a what do you call week zero. We have to cover a lot of ground today
Yeah.
to make you aware of these things, not understand. It is not for making you understand. You need to know the terms. Okay, you don't need to understand everything. But at this point of time, I don't want to spend 2 weeks explaining all these things one by one, right? So what we will do is we will be discussing as part of the data scientist's life. You will be working on certain scenarios, right? So when you are working on one particular scenario, like for example, you are working on Spark. Okay, so we will discuss more about Spark, and we will have an opportunity of discussing about Spark much more effectively.
Okay. Okay.
Okay, so yes, this particular class, today's class, week zero, is for what do you call making you folks understand the whole landscape as a this one. It's like there is a nebula. In nebula, there are about some billions of stars, and like this, there are 15 other nebulas. Okay, if you want to start learning about Alpha Centauri in detail in the same class, you will not be able to understand. Right? So we will discuss these things in later classes.
Okay. Yeah.
Okay. So basically, whenever we are discussing about certain scenarios, do you remember we discussed about something called Falcon? For example, we are talking about preparing our data from Twitter and loading the data into something and then start analyzing. So we have discussed about Falcon. You heard about Falcon. So we will discuss a little bit more about Falcon and do something about it. And then we will go from there.
Right. Okay.
Right.
Okay.
So that way, okay, then you will understand. Okay, that day I heard about Falcon. That's not going to be a new terminology for you. Yes, I understand you did not understand today totally. You know only something about it. That day you will understand fully.
Okay. Yeah. Yeah.
All right.
Yeah. So just like what we had we had a bit of hands-on experience today on Hive, you were doing it and we were following it real time. Are we gonna do the same? Are we gonna follow the same approach across these tools? The Falcon, Scuba, Uzi, or
Not everything. Not everything. So basically, what I'm trying to do is I will give one example for some of the things we are following the Pig. We are doing on Spark. We have done something on Hive. Okay. We are doing something on the Zeppelin. We have looked at Zeppelin. We didn't do anything on Zeppelin and all these things. Okay. This is fundamentals. Okay. But actual things, what we need to learn, okay, is how do we take the data? How do we store the data? How do we analyze the data? And how do we create the projections?
Okay. Yeah. Okay.
All right. So while doing these things, so basically, when you are talking about data, there are three things that you need to really consider. The first thing is identification, sourcing, understanding, and taking the data. That is the first part. Okay. The second part is managing, organizing, securing, protecting, and modeling the data. The third part is analyzing, projecting, and giving value to the data. Okay. So these three parts, whenever we are discussing about one of these parts, we will discuss about some of the tools that are helping in that particular part extensively.
Okay. Yeah.
Okay.
Fine.
That way you can learn much more easily.
Yeah.
All right. So if I speak about, like for example, Falcon today extensively, and I have to speak about what do you call, then let's say we spent about 3 days discussing about these different things. Then when we are doing actual exercises, we will forget about these things. Right? So when you are doing actual exercises, you will be actually bringing these pictures into bringing these terms and looking into the clear, detailed picture.
Okay, that's fine. Yeah.
Okay. All right. Srinivas, you have to somehow set right your Apple. So I have sent you some videos as well from Microsoft how to set it right. I don't know whether they are any helpful or not.
Yeah, I've seen all those videos. You know, I did bit of research on forums also, but nothing is helping me honestly. And then for almost good part of the session today, I couldn't even catch the presentation real time. You know, I was just following the presentation.
So what I will do is from next presentation onwards, I will send the presentation upfront.
Okay.
So for such kind of people, sometimes some people might be suffering with slow broadband speeds or whatever it is. For example, my broadband speed is about 70 Mbps. So yeah, some people might be having some problem. Okay.
Mine is 0.4 MB.
Okay.
Who is this?
Srikanth, sorry.
Srikanth. Yeah. All right, Srikanth, what is happening? Are you able to see the presentation and whatever screens I have shared with you today properly?
Yes, Ram. I was very fortunate today. Yes, I was able to see all that you showed apart from just 5 minutes. Yes.
Okay.
Sorry.
That's fine. Okay. So Srikanth, are you able to also hear me properly? And did you understand the terms that we discussed? And are you able to get, or do you have any questions?
No, Ram, I'm pretty comfortable. I've understood everything. That's great. Thank you. And if you could send the presentation from the previous class yesterday and today's one, if you could upload it to Google Drive and send the link to us, that will be helpful.
Okay. All right. I'll do it.
Thank you.
Vamshi.
Hi, Ram. Today was a bit unable to go with the practical work, but by the theory works, what the questions what I have is that, you are saying about some of the data life cycle and the ETLs in the Hadoop Apache. So is that for the same? Do we have for the same process? Do we have the multiple interpreters or multiple applications on the Hadoop Apache? Like basically, my question is that, why you more concentrating on the Hive and Pig? Is that the company's most used, or that only be used for the data science? Or basically, if I go for a Hive, mostly that what I see is that, you're using the SQL language. But when it comes to the Pig, it was totally a bit different, looks like. So why you choose more on the Hive and the Pig? Is that only those two things are related to the data science, or that's extensively used for same for upload and for there is a different way in the Hive and there's a different way in the Pig.
Absolutely.
And maybe that could be different way in other languages. So my question is that, so is it like a scenario based we use these languages, or is it more particularly like we need to use this language? Our company decides that no, we need because it's a better way, or we go this one. So if you could able to answer some of those questions when you are upgrading, see, you are describing it as like a definitions on the Falcon or everything. Okay. instead of
Yeah. So
okay.
basically, as I said earlier, I think for Srinivas, there are three parts in the data, right?
Yeah, yeah.
Okay. So basically, identification, sourcing, profiling, and preparing the data. The second part is managing, organizing, and the third part is querying. Okay. So there are certain tool sets that are available. There are certain tool sets that are available for the part one. There are certain tools are available for part two and part three. Okay, so that is what we have seen in the Hadoop framework. Okay, so for example, we have Falcon is something, what do you call, is the, for example, I am showing this one moment. What I'm trying to do is here, I want to show you again this framework. Okay, this is the framework what we have been seeing, right? This is the framework what we have been seeing. So in the data lifecycle and governance basically is responsible for the part one. Okay, workflow is also responsible for part one. And data access, thus, yes, I have actually showed lot of concentration on Hive, Pig, and all these things. As part of the data scientist, you have two responsibilities. One is how to actually make sure that the data is available on your systems. Okay, wherever you are doing the data science.
Sir, someone's TV is on, looks like.
Yeah. So, okay. So basically, if you are looking at it, so basically we have discussed more about Hive, Pig, and all these things today. And I have also said we will be discussing more about Storm, Spark, and Solar. That is because as part of the data scientist, 10% of your job is to identify the data, load the data into the target, and 80% of your job is to analyze the data, and another 10% of the job is to present the information to your stakeholders. Okay, so as per the course, we are learning data science. So we will be learning a little bit of how do we load the data, and then more of how do we analyze the data, and how do we present the data. Okay.
Yeah.
All right. And of course, while discussing about these three topics, we will be discussing about a number of things.
Yeah.
Madhvi, how are you?
Hello, Ram Garu. I'm okay, Andy. Most of the questions have been answered. Just wanted to ask you, how far are you going to teach us Hadoop? You showed us the framework and everything. Are you going to deep into the details or not? Or what would be our next topic?
Yeah, our next topic is going to be basically again a bit of Hadoop and a little bit of practicals on Hadoop. However,
Okay.
I want to get onto statistics as soon as possible. Okay. So, and Python, these are the things that are most important for you folks. Okay. So, how do you start analyzing the data?
Okay.
So yes, our next class is going to be a little bit of this Hadoop. Okay. And what I expect you folks to do is, I want you folks to do some laboratories on your own. Okay, if you have any problem, you can come back to me. All right. Otherwise, basically, we will be getting onto what do you call statistics pretty soon, because that's more important for you rather than this knowledge is necessary for you to understand. Okay, while it is not essential.
I mean, do we have to learn more of the Hive, or we need to learn Python or R?
You are not learning these things. You are just understanding these things. Okay.
Oh.
Basically, because when you go to work as a data scientist, you never know what is going to be there in the background. It could be SAP HANA altogether.
Okay.
Okay. So
any querying language.
Yeah. So basically, what you need to do is you need to understand a little bit what is the background that is working on, that we are working on. Okay. So this particular exercise will give you a little bit of knowledge how we work on these things. All right.
Okay. Right. Okay. Yeah. Probably when we have more classes, we'll understand it more.
Yeah.
Okay. Thanks, Andy.
So how are you, Raghava?
Thank you, sir. Thank you. Thank you for introducing us to this so many terms.
Mm-hmm.
And Srini asked and Praveen asked, so much of my questions is been answered there itself. So I'm comfortable with whatever the lessons I learned today.
Okay.
Hopefully we will get to the bottom of the Hadoop training by whatever the problems we have this week. Probably we will sort it out by next week, I think.
Yeah. So we will be doing some good examples on Hadoop. However, this is not actual. This is not a Hadoop course. Okay. Yeah. So it is a data science course. I want to get to statistics as soon as possible, as early as next Sunday.
Yes,
okay.
Sure.
So what I suggest is I will keep this environment open for the end of the day today. Okay. I want you folks to go. I have sent some URL. I will also send it on LinkedIn, as well as I will share that URL on the Google Drive. Okay. So I want you to folks to do some tutorials as well. There are tutorials. We don't need to reinvent the wheel. Okay.
Sure. Thank you, sir. Thank you.
Who else is there? Kumi? Any questions from you?
As everyone else said, it's a lot of terms, and I think we need more time to keep up to the what terms you're saying and what it means and everything like that. But
yeah.
I think everything is good.
Yeah. Ganesh?
I think I agree with most of the things covered by Vamshi and Praveen. Only one thing I like to suggest is the syncing time. Once you have explained the definition of one particular thing, we need some time gap, so that whatever the terminology, the wordings, we are writing or we are trying to store that terminology in our head. By that time, you are getting into another topic. Okay. So that is only one request. Is if you can give us some syncing time for understanding the word, or maybe like today's session is most important thing is the architecture. We have discussed mainly about the architecture, and you rightly pointed out what is the topic, like with little bit more explanation on the data flow, like what will happen. So this is a platform operating system, and this is a database internally, and there is a script used, and there is a database. With this, keeping the architecture, and maybe if you would have given like a Word document where you write the definition of what is what, and one line about each, either you written it before and given it to us, or maybe you make us to write, because the entire course is based on this architecture. What I mean to say is understanding important. The importance of this architecture is very, very, very important for us. Maybe some gap, and maybe you tell us, we will write, or if you provide a document with definitions, that will help. I think that is the only request from my side.
Okay. I will try to do that. However, having said that, I want to correct you one thing there. Our entire course is not based on this. Okay, this is only a tool for us to do the course. Okay. Our course is a data science course. It is not, this is not the entire course. Will not be dependent on that. You will understand what I mean by. Okay.
Okay.
All right. Pami?
Yeah. Yeah, since I'm new to all this tech terms, I kind of was slow to pick it up, but I understood it in the end, so it's fine.
So this particular course is for mostly for business oriented, business facing people. Okay, people who are actually working with the business stakeholders. I understand these tech terms sometimes can be overwhelming, and don't worry about these tech terms too much, and don't the only thing is moving the data, working with the data, and presenting the data. These are the three things that you need to learn, and you will learn these things. Okay. That could be any environment. Okay, but mostly the Hadoop environment is most famous in the data science environment. So that is the reason I'm spending a little bit more time on the Hadoop environment. Otherwise, I would have done it on Excel.
Okay.
All right. And remember, the big data environments, MongoDB, Hadoop, and all these kind of things, irrespective of a number of the tool sets and all these things, these are all nothing but glorified Excels.
Okay.
Okay. Right. Okay.
That makes me feel better.
Yeah. Any more questions from anybody?
Ram, can you hear me?
Yeah, I can hear you, Srini.
I posted a question just now on this one.
I do understand you. I am not going to give you a lot of exercises on this Hadoop environment. Okay, but when we start statistics, you would ask me, can you please stop giving me exercises? Okay, that is more important. So when you start learning Python and all these things, you will get a lot of exercises. This Hadoop environment is only for awareness. Please remember that. You don't need to worry about it. You will not be worried about it in your entire career. Okay? If you are seeing some agencies posting saying that I need data scientist who understands Kafka, that agency is posting some fake job advertisement. Okay? Simple, as simple as that. If you send a CV saying that I am an expert in Kafka, you will not even get a call back. Okay, so likewise, it is the same thing. So you, as a data scientist, you won't be talking about technology terms. Okay, but today I have shown you the architecture, so that you will be. And my presentation speaks more about MapReduce, Hive, these things, because that is what we need to worry about. Okay, because basically we need Hive to, it is query language tool, right? Query tool. MapReduce, run the queries faster. Tage, run the queries faster. Pig, write the SQL scripts and all these kind of things. Those things we need to worry about, nothing else.
Ram, before winding, can I say something?
Yes, please.
Shrikant. Yeah, so see, I'm a data warehouse and business intelligence expert. So if you whatever be you're trying to say from past half an hour on the feedback, the thing is, so data science is business intelligence, and Hadoop is nothing but your ETL underlying ETL. So to do the BI reporting, you need to kind of have an understanding on the background of what's happening. That is Hadoop. And business intelligence, I do a lot of data analysis on the business intelligence reporting to show to the stakeholders how better I can show the data with the data that I have in the data warehouse. So that is what is Hadoop, the loading of the data. And data science is the new that has been evolved, where you show the how well you can show the based on your Python and machine language, and then you can show the present the data well.
Yeah.
Is that correct?
Yeah. So basically, what Hadoop is, see again, Hadoop is a framework. There are number of tools on the Hadoop. So if you are looking at my presentation at this point of time, okay, so in addition to these tools, there are some number of tools. There are some number. Each one itself is a project. For example, Falcon is a project, Atlas is a project, Scoop is a project, and all these things. So as you rightly said, it is the underlying system to store the data. Okay, and as a business analyst or a data analyst or a data science analyst or whatever it is, you will be understanding the business requirements and trying to deliver the required things using the power of this Hadoop framework. Okay, so you don't need to know everything in Hadoop. You don't need to know, for example, Flume. So you don't need to know Kafka, you don't need to know Atlas, etc., etc. Okay. So some tools, yes, you need to.
Yeah.
So, but Python and R, the ones which will be mostly focusing on that, are we going to run these ones on Hadoop framework, or is it sitting outside?
You can run these things on the Hadoop framework. You can run these things on on any framework actually. You can run these things on MongoDB. You can run these things on Oracle. You name it, you can run these things on there.
Okay.
Okay. It's not something which actually hard. There is no hard and fast rule. It has to run only on Hadoop. You can do many things using Excel itself, using Python and R. But of course, we will not be learning working on Excel and Excel here in this class. But in future, when you go to your daily life as a data scientist, you might have to work only on Excel. That's the life. Okay.
I have a question.
Yes.
You mentioned tutorials earlier to understand how to where can we get them from?
I sent on the Skype a URL. There are tutorials. I will send it by on the WhatsApp as well, and I will also put it in the Google Drive.
Okay.
Okay, thank you. Then signing off.
Yeah, thank you very much, everybody.
Thank you. Thanks, Ram.
Thanks, Ram. Yeah.
Okay. Bye. Thank you.